This is problem 51 of Neetcode 150, subtree of another tree. Alright, in this problem, we are actually going to use the exact same algorithm that we used for the problem 50 called same tree. So I do recommend you to do it prior to going for this problem. So the other problems I recommend is same tree, and it is also an easy problem. So let's go ahead and read the instructions. So we are given the roots of two binary trees, root and subroot. So root is going to be um, the longest tree, and hopefully subroot is going to be somewhere within root. So we are going to return true if actually subroot is inside the root. Otherwise, we're going to return false. So I think that this picture here is pretty um, uh, I think it talks for itself, right? It's self-explanatory. So you can see it. We have somewhere here a 2, which has a left child of 4 and a right child of 5, and the subroot is exactly that, right? So it starts with a 2 and it has a left child of 4 and a right child of 5. So here I'll let you guess what the output is for this example. I'll give you 5 extra seconds. And there you go. So it is false. And it is false basically because the subroot stops at 4, right? So you might think that there is the exact same sequence, that 2 having a child of 4 and another child of 5, but the thing is that um, the the 4 itself has to stop at 4 because the subroot stops at 4. So in this problem, this is an edge case, right? You have to ensure that if any of the child of this the root um, where you have a sequence that is exactly the sequence of the subroot, so you have to ensure that if one of the child of the subroot um, is also having a child in the root, you have to return false. So um, let's go see this example I made. So um, we have here a 1 with 2 childs, 2 and 3, and the 2 has 2 childs, 4 and 5, and this is the root, okay? Let's just write error, and this is the subroot written in blue. Okay, so this is the subroot. Looks more like a T, but okay, I'll pass over this. And it has basically a 2 with 2 childs, 4 and 5. So what we are going to be willing to do is actually use recursion, and for each recursion we are going to have the algorithm of the same tree. So we are going to check for the 1, for example, is 1 the same tree as the subroot? No. So we are going to go for its child, and is so first, is a right child the same as the subroot? Well, clearly not. It is not. And is it is a left child the same? Well, in this case, yes, it is the same because you can see that it has 2 childs, 1 4, 1 5. But if we add a 7 here, for example, well, you can see that this entire thing is not the same as the subroot. So in this case, we'll go one step further, and we'll go see 5 and 4 and ask whether 5 is the same as the subroot, and on and on. And now we are ready to code this problem. So let's first of all create the function same tree the same way we did it in the previous problem. So this is actually gonna take the same 2. Well, it's gonna take the root. Okay, let's call it the root, or let's just call this S and T, right? It's gonna be a little bit shorter. So it's gonna take basically T, which is the subroot, and also it's gonna take S, which is in this case is the root, or like the smaller tree within the root. Okay, so how do we build the algorithm for figuring out if they are the same tree? Well, we are going to use recursion. So a depth first search algorithm, and we're gonna have a couple if statements. The first one is gonna be basically to check if both are none. So because the trick here is that we are gonna go see every single values for the threes, and if at every single value the structure and the value itself is exactly the same, we are going to return basically a recursion call, and we are going to basically recurse until we reach the end of the tree, and at the end of the tree the two childs are none. So at this point, if we have a none for the S and a none for the T, right, this is where we can return through. All right. And now what if we have a S and we have a T? So what are we going to do in this case if both are present? We have a couple possibility here. If both are present, it is possible that they either have the same value or they don't. Okay. There's also another possibility that we have a S but the T is none, or we have a T but S is none. I'm actually just going to put everything in the else statement and return false. So just like this. Okay. And after this, we can take the case where S and T are there and S dot val. So both values are the same. So if this happens, this is where we are going to call our recursive call. So we are basically going to return self dot sym3, where basically S is going to be equal to the S dot left, and the T is going to be equal to phi dot left, because we want to compare both left childs of the left childs of both threes. Okay, so this is exactly what we did in the problem called sym3. So S left, T dot left. All right, and we are also going to do the same thing with the right childs of both trees. So sym3, just like this, with S dot right and T dot right. So we are going to recurse until we reach the end of the tree, and at the end of the tree we have this first if statement where S and T are not S and T are not, and we are going to receive a true in this case, and we are going to bring this true back to the top of the tree in our way back from the recursion. So we are going to return 3 in this case. Okay, so now we are set for the check of whether the trees are the same. Okay, and actually I made an error with indentation, so let's just quickly fix that. Cool. Okay, so now let's think of how do we handle the actual algorithm where we have to check for each node of the root if it is equal to the subroot. So first, what I can think of is what if we don't have actually a subroot, right? What if it is a none? Well, actually none is inside a root, so we technically have to return true. So we are going to make that check. So if not subroot, we are going to return 2. All right, once that this check is done, if we didn't return true, it must mean that T exists. So if it must mean that the subroot exists. So if there is a subroot, we have to ensure that there is also a root. Okay, so if at this point, if not root, right? We are going to return false, okay? Because we know from this order that if there is not a subroot, we will already have returned through, meaning that if we actually reach this line, it means that there is a subroot. So if there is no root, we are going to return false, okay? And after this, we are going to call a recursive call, okay? So we are going to say if self.sem3, and within this, we are going to pass the root and the subroot initially. Okay, so if this is true, because we know that this function is gonna return either true or false, and return a boolean, well, we are gonna return true. Okay, so if this happens to be true, it means that there is an actual subtree existing. And otherwise, what we want to do is we want basically to return our recursive calls. But this time we want to check if the tree starting from the left child or the three starting from the right child is actually equal to the subroot. So what we're going to do is that we're going to call ourselves that is Subtree. All right, where the three that will take the place of the root is going to be equal to the root that's left. The t is not going to change, right? And also, since this is a return statement, okay, we only need to have one solution to return true, right? So we whether by recursing we got on the left branch an actual copy of that subroot, we are gonna return true. So the left side doesn't need to have this exact same copy. So this is why we're using a or statement here. So same logic here. So is sub3, where we are gonna use this time the right side and the feet. Okay. So let me just put that on 2 lines to improve the visual experience. Okay, and this is it. So we are first handling the edge cases, then we're gonna check on each recursion call if we have the same tree, right? So initially we're gonna start with our one here. So let me just clean that up a little bit. Right, so we're initially going to start with our one, and we're going to put this one in the function that we created, same tree, and it should give a return of false, right? Because they're not the same. So after this, we are going to recurse again, and we are going to go see if our left child we're going to pass our left child and our right child in the same tree with this subroot. So if any of them are actually the same subtree, right? We are going to return through. Okay, so let's try this code. We have an error. So the name T is not defined. Oh, okay, yes. Because I said T in my same tree function, but in the is sub3 function, there's no such thing as a t variable. It is called the subroot. Okay, so this should work now. Let's try this out. There we go. Okay, so I hope you learned from this video, and I hope to see you in the next one.